Welcome to the video for problem 3.6 of Engineering 623. This problem reads as follows. An attenuator can be made using a section of waveguide operating below cutoff, as shown in the accompanying figure. If A is equal to 2.286 centimeters and the operating frequency is 12 gigahertz, determine the required length of the below cutoff section of waveguide to achieve an attenuation of 100 dB between the input and output guides. Ignore the effect of reflections at the step discontinuities. And an additional instruction was given, which is repeated here at the beginning of this problem, which is that you should view A, or A over 2, depending on which part of the waveguide you're looking at, as the separation between the plates of a parallel plate waveguide. Now, if we look in the book, we see that for both the TM and the TE modes of a parallel plate waveguide, beta is equal to the square root of k squared minus n pi over d squared. So for either the TM or either the TM1 or TE1 mode, we have substituting in n equals 1, beta is equal to square root of k squared minus pi over d squared. Now again, in the attenuator portion of the waveguide, we are supposed to think of that separation as being A over 2. And so substituting that in for D, we get beta is equal to the square root of K is equal to omega over C. So we plug that in for K, and then we plug in A over 2 for D, and we get this expression. And then recall that A is equal to 2.286 centimeters. So we substitute that in, and finally get that beta is equal to plus or minus J times 111.26. Now, when we calculate this in dB, we want that to be over the length L. So in other words, now we're going to take beta, multiply it by L, then use that as the exponent of E, then calculating that in dB by taking 20 log, we should get 100. And I've put in the negative sign here because it is attenuation. And so if you do just a little bit of math, dividing both sides by 20 and taking the inverse log of each side and you get this, and then now take the natural log of each side and you'll get this, and finally we end up solving for L to be 0.1035 units or meters, and so in centimeters that gives us L is equal to 10.35 centimeters. So once we know to view A, or A over 2, as the separation between the plates of a parallel plate waveguide, this problem becomes rather straightforward. And that concludes our discussion of problem 3.6.